on the second hybrid lesson for this unit, and we are going to continue with solving linear inequalities. All right, so let's look at what we're talking about. So the previous section looks like this. Our current section looks like this. All right, so what's the difference? What's the difference? Problem 1 is an equality. And this second problem here is an inequality. The only difference is what the answer means. All right, so we'll go over the old one just to make sure. So always, label the type of terms you're dealing with. Now, same thing over here. We have variable term, constant term, and another constant term. All right, so this one starts off with rule number 5, where you have to get the variable term by itself. All right, so if we have to get the variable term by itself, we must move this constant term, this -4. And you move a -4 with the opposite, which is a +4. Whatever you do to one side, you do to the other side. Underline because you're adding the opposite. The 3x comes down. The 4's cancel out because we moved them. Equal sign always comes down. And 2 + 4 is 6. All right. And then the final step, which is step 6, is to get x by itself. So you get x by itself by dividing both sides by that 3. And what's left over, x comes down, equal comes down, x equal 2. So the answer to this equation that makes both sides true is 2. 2 is the solution to that equation. Now, on the inequality, you do the same exact steps. We're going to start with rule 5 again. Our goal is first to get the variable term by itself. So we move this constant term. You move the constant term by adding 4 to both sides. And what happens? The 3x comes down, the 4 cancel. The inequality comes down. All right. And then 2 + 4 is 6. Now you have to actually get the x by itself. So you get the x by itself by dividing both sides by 3. X, then you bring down the inequality, and 6 divided by 3. And with that is we must graph the answer we have here. So we'll draw a number line. And the only number we need is 2. It says everything, all numbers less than 2. So we shade back this way, make the arrow big. And will it be an open interval or closed interval? It didn't say equal to, so we're going to do open. All right, do not include 2. Now, the interval notation for this answer is, we're going from left to right. So when we go from left to right, the first thing we hit is a negative infinity. Negative infinity, comma. What's the number we stop at? 2. Now we need our intervals. Always open on infinity, and because we have an open circle here, it doesn't say equal to, we have open here as well. That's the only difference. What I taught you last class was how to represent your answer. Your answer will always be a graph and your interval notation. Now, I want to add a rule to our rules. All right, so we have 6 of them. You do the same thing. The only thing I want to add to this is when dividing by a negative, when divided by a negative coefficient, that's rule 6. All right, comma. Flip the inequality. That's it. When dividing by a negative coefficient, which was in rule 6, make sure we flip the inequality. So over here, if that was a negative 3x here and we divided both sides by negative 3, that inequality will go the other way. All right. So before we leave this, let's go on and explain what's going on. So in all the numbers that are less than 2, which include 0, 1, I should do the other way. 1, 0, -1, -2, so on. Any number and ... I can put back into these equations to make it true. All right, here we go. We know that 0 is less than 2, and therefore, if we plug 0 into our equation, it should come out true. Here we go. So 3, that's 3x minus 4 less than 2. So I'm saying if we plug in anything in this range, our answer will be correct. We plug anything in this range, it will be correct. So let's plug in 0. So 3 stays the same because that x is right beside the 3. We are multiplying. So 3 times 0 minus 4 less than 2. All right. What's 3 times 0? 0. We bring down to minus 4 less than 2. 0 minus 4 is still -4 less than 2. Let's see if that's true. Is -4 less than 2? Yes, it is. So any number that's less than 2 will make this whole statement true. All right. Let's try one that's not less than 2. Let's say you pick something over here. Let's say you pick the number over here, a number greater than 2 or equal to 2. All right, let's try 3. So in this equation, it's still, the original equation is 3x minus 4 less than 2. Let's plug in 3. 3 is greater than 2. Let's plug in 3. So 3 is here, but the x we're plugging in, we're saying that solution is 3, and we bring everything else down. All right, 3 times 3 is how much? 9. And then the minus 4 less than 2. 9 minus 4 is how much? 5. Is 5 less than 2? That's false. So anything anything larger than 2 will make this statement false. So there's not a solution. Anything in this area here is not a solution to this equation. So the whole thing you're trying to do is find out what range of numbers, what set of real numbers will make the statement true. That's it. When we had an equation, there was only one number that'll make the statement true. So we plug that 2 back into here, both sides, that will make that whole statement true. 2 going in the x, 2 where the x is. 3 times 2 is 6. 6 minus 4 is 2. That's 2 equals 2. True. So what we're doing now is the same stuff. The symbol in the middle that separates the two sides is now different, which means that you have to provide the graph and the interval notation. I won't worry about set. Let's go ahead and practice. So only rules that are different is we added one in the end. We added a stipulation on the end. All right, let's try it again. So we have 8 minus 3x less than 17. All right. Now, for my people, you know who you are. If you're working on the highlighted ones, starting at rule 4, go ahead and give me what we got. The type of term. We got constant terms, variable terms, constant term. All right. And you have your, get something lighter than that. You have your inequality in the middle, treated just like an equal sign. So your whole goal is to get the variable by itself. But if you start off with rule 5, it asks about variables on both sides. We don't have, rule 4. That talks about variables on both sides. We don't have variables on both sides, so we go to rule 5. Our goal is to get the variable term by itself. So we got to move this constant term. Now we know. How do we move a constant term? By adding its opposite. So if we say negative 8 here, whatever we do to one side of the inequality, we do on the other side of the inequality. The 8's cancel out. That minus 3x or negative 3x comes down. The inequality comes down. And 17 plus a negative 8, put in the calculator, you get 9. All right? Almost the last step. Rule 6 says get the variable by itself. So we divide both sides by negative 3. Whatever we do to one side, we're doing to the other side. And now the negative 3's cancel. We're left with x. But wait a minute. The rule that we wrote says whenever we have to divide by a negative coefficient, that's rule 6, we have to flip the inequality. Let's do that. All right. So instead of that being a less than sign, we're going to flip that to a greater than, and 9 divided by negative 3 is negative 3. Let's graph that. What's that statement read? All numbers what? Greater than negative 3. Cool. So we draw a graph. We really just need that negative 3 here. And it says everything greater than negative 3. So we go on to the right. All right. And because it didn't say equal to, we open it up. All right. Interval notation now. Remember, we're going from left to right. When we're going from left to right, the first thing we hit is the number, right? So we say negative 3. Then we keep going, and then we hit that infinity. What type of infinity is that? Just regular infinity, or positive infinity. Now we need intervals. Negative 3 is open, so we curve. Infinity is always open. All right, that's the answer. All right, we're saying that any number that's greater than negative 3 will make this statement up here true. All right, let's do it again. Another practice problem. Let's do, try this one. All right. So remember, highlight what you have. We have a variable term here, constant term here, variable term, constant term. And we have a inequality. All right. So when deciding what rule we're going to do, we know that we have variable terms on both sides. So that's rule 4 automatically. We need to get the variable terms together. Now, I'm going to go against my old rule and move the largest one. All right. So I'm going to move this 7x with a negative segment 7x. So anytime you want to move a variable term, you do its opposite. So 5x plus a negative 7x will give us a 2x. And I'm going to bring everything else down. What kind of 2x though? Negative 2x. Bring everything else down. Inequality comes down. The x's on that side cancel out, and the -8 comes down. All right, now we are trying to get the variable term over here by itself. So what's over there with it? That -2. Well, we got to do the opposite. The opposite of -2 is or -2 is a +2. Whatever you do to one side of inequality, you do to the other side. And the opposite we underline. All right, that 2x comes down. 2's cancel, inequality come down. Don't forget the negative because that will throw your problem off. And -8 plus 2 is a -6. All right, last step. We now have to get the variable by itself, just the x. So we divide both sides by the -2. The -2's cancel. X comes down, but because you divided by a negative number, that inequality now goes the other way. -6 divided by -2 is a +3. All right, now we're saying all numbers greater than or equal to 3. All right, cool. Draw our number line, and all the number we really need is 3. And we said everything greater than 3, which is going this way. Now, it says greater than or equal to. So our interval is closed because we now can include the number 3. All right. Now remember, we're going from left to right. Going from left to right, the first thing we hit is 3. Then we end at positive infinity. All right. So now talk about the interval. Because we closed at it, we include in 3, we have to box that in. We have to close that. And infinity is always open. All right. Let's keep going. All right, let's try this one. All right. Eight times 5x minus 4 decreased by 6 times the sum, 3 times the number, and 5. Let's just do less than -7. All right. Now, because this problem has a parenthesis in it, we know we starting with rule number 2. All right. Now, if this is not a rule number 2 problem for you, I still want you to write it, but don't stress about it. Just go with us. All right. So now, rule 2 says remove the parentheses. That means we're going to say 8 times both of these and -6 times both of these. All right. Let's do it. 8 times 5 is 40 with the x. 8 times 4 is 32. Then -6 times 3 is -18x. -6 times 5 is -30. Less than sign, -7. All right. After rule 2, rule 3 says combine the like terms. Well, we have 40x and -18x. So 40 and -18. And we just combine those and we get 22. All right. So that'll be 22x. And then we have -32 and -30. So just combine it, -32 and -30. And we get -62 when we combine. So because that's negative, it's fine to say -62. Less than -7. All right. Now, we're trying to get the variable term by itself. So we add 62 to both sides. Now we're down here to rule 5. Add 62 to both sides. And we get 22 comes down. 22x comes down to 62's cancel because we moved them. Less than sign here. And we get a positive 55. And then to get the x by itself, we divide both sides by 22. And we get x. And then we bring down the inequality. And 55 over 22. There's 11 going into both of those. And we get 5 over 2. So we have x less than 5 over 2. All right. And, that's 2.5. But I'll take 5 over 2 if you want. So we'll graph that. Two and a half. Everything less than 5 over 2. All right. It goes back that way. And because it doesn't say equal to, we're going to open that circle up. And our interval notation will be, remember, we're starting from here, left to right. So the first thing we hit, what kind of infinity is that with that arrow? Negative infinity, comma, 5 over 2. Always open on the infinity. And because it's open or not equal to, it doesn't say or equal to on the 5 over 2.